Hello, good evening, everyone. I welcome you all to GRE Preparation Made Easy Quantitative Reasoning class by Mrs. Annapurna Murugan. Here are a few instructions for the participants. Make sure you have a stable internet connection and noise-free environment. We recommend you to use your earphones for best experience. Also, please respect your instructor, your classmates, and yourself. Do not write anything disrespectful. We also have three packages: bronze, silver, and gold. If you upgrade to silver and gold, you'll get extra benefits like evaluated mock tests and expert university recommendations and so on. We have free profile evaluation with our experts, comprehensive evaluation, university shortlisting, recommendation reports, and doubt clearance. We have free live IELTS classes, that is from Monday to Friday, 7:30 to 8:30 p.m. It is a 4-week course, and free Duolingo classes, Monday to Friday, 6:30 to 7:30 p.m. It is a 2-week course. We also have this virtual education loan fair. It is this Saturday, that is 4th November, 7 p.m. to 8 p.m. You may register for free. You will get benefits like personalized loan assessment, instant loan offer, discounted processing fees, cashback incentive, and so on. We have the special offer for gold package starting from rupees 499 with extra benefits. You may contact us for further details. Here are a few achievements. This is the Ubergrad website. You can select the country, course, and specialization. When you go and explore, we have countries, universities, courses, and exams. You may get all the information through this through Explore. When you go on solution, we have free profile evaluation, talk to counselor, country recommendations, test preparation stores, additional services. Also, weekly blogs are uploaded. You may go through them. To contact us, you may call us, WhatsApp us, or mail us. We also have my test preparation. When you click on GRE view course, you'll get the weekly handouts and recordings. I'll be sharing the link. For any other query, you may ask at the end of the session. Thank you. Ma'am, you may start.
Hi guys, good evening. I hope everyone doing good. Okay, today let us start off with further arithmetic. So that is your cyclicity. That means the numbers. So with regards to numbers, we need to discuss about cyclicity, IGP of a number, and then we'll be working on few problems as well. Okay, so I'll be presenting the screen for you guys. Good evening, Imani. Yes, let me share the screen board. Just give me 1 second. Yes, here we go. Right. So we have certain things that we need to discuss here. So the first and foremost thing here I would like to discuss would be the IGP of a number. What is this IGP of a number? Here, they would be asking, so basically this will be based on, so this one factorial, or basically this IGP could be taken for any number, but most frequently, so we'll have the questions on the basis of your, this one, what is that? I can say, it will be based on factorials. Okay. So for example, what does this IGP means? The IGP is nothing but the greatest index of power, or we can say, so basically index of greatest power. For example, if I take any number, okay, say for example 7, so 2 0 I have 720. If I take, you people will be just factorizing here to find the greatest index or the index of the greatest power. So we can, how we can do, we can prime factorize. 2 3s are 6, 2 6 are 12, 0. Then 2 1s are 2 8s are 0s are 2 90s are. So then this one is a 2 45s are. So then we have so 9 in the sense 5 9s are. So 3 3s are 3 1s are. That means the number could be expressed as 2 to the power 4 into 3 square into 5. Okay. So which is the number which is having the greater power? Which number is present more times? It is 2. Therefore, IGP of 720 is what? 2. Why? So 2 is the index and this index has the greatest power. Therefore, we can say that 2 is the IGP of this given number. Okay, this though you people will be finding out. Okay, so but if they give, find the IGP of 2 in 25 factorial. Now the number is here 25 factorial. Usually what happens when you guys write the factorials, so how do you write 25 factorial means it will be like this: 25 into 24 into 23 into 22 into, it goes up to 1 year. So now you need to find the greater index, the index of the greatest power of 2. So in 25 factorial, so how can we find? So many numbers are there. So we don't know how many 2's can divide 25, how many 2's can divide 24. So that means we need to find that. So what you need to do is, so kindly take the prime factorization only. But here you need to keep dividing with 2. Okay. So what, because they are asking for the IGP of 2, so therefore you need to divide with 2 only. So here you can say 2 12s are, no matter what the remainder is. So even if there is a remainder, we can oversee that. So I'll just write the remainder here. So for your case, so 1. So 2 6 are 12. Here the remainder is 0. So 2 3s are 6. The remainder is 0. No issues. 2 1s are 2. So here the remainder is 1. So let us not consider these remainders. Okay, what we should not consider? We should not consider these remainders. So what we can do is we can take these elements, okay, these consecutive divisions, what we have taken, so that we can take. Okay, so that means what, the IGP of 2 is how much? 12 plus 6 plus 3 plus 1. So that is 18, 21, 22. So how many 2's are there in 25 factorial means? How you can find out? 25 in 25 factorial, how many 2's are there? So 22 2's are there here. Okay. So this is what we people need to find out. So this is the IGP of a number. If they ask IGP of 2 in 25 factorial, what we need to do? We need to consecutively divide, and so we need to take all the quotients and sum it up. Then we'll come to know, so how many 12s, how many 2's are there. So in 25 factorial. So just in the same case, let us try to find out, find the IGP of 3 in 44 factorial. In 44 factorial, kindly find the, so 3 IGP of 3. Okay, that means how many 3's are present in 44 here. So I'll show you guys once again. Kindly see here. 44, na? So with 3. So 3 ones are 3. Okay. So then how many times it will go? So it will become 14. So 3 fours are 12. So 2 remainder we have. Then 3 fours are 12. 2 remainder. Then 3 ones are 3. 1 remainder. Remainders we are not going to take here. We only have these numbers. So therefore what? So the IGP of 3 will be what? 14 plus 4 plus 1. So that is nothing but 19 threes. So we do have in 44 factorial. How many threes will be having? Will be having. So 19 threes in 44 factorial. Getting it, guys? Yes. Which links you're talking about? I guess all the links are here. Okay, so this is the IGP of a number that we basically have. So I guess you people understand about this IGPs. Okay, so now we have a twist here. So what is the IGP of 10 in 25 factorial? Now, how do you find? We need to identify what is the IGP of 10 in 25 factorial. So, see, 10 is composite number, isn't it? What is this 10? So, 10 is a composite number. You cannot directly take here this one. So, 10 can be split into what? 2 and 5. How can you split? So you can split 10 as 2 and 5. So now individually you people need to take the IGP of 2 and 5. What you need to do? You need to take, so individually, so 2 and 5 here, and then you should find out. So 25, 2, how many 2's were there? So you can see that in 25 factorial we had 22 2's, isn't it? We had found that. So therefore, let me not again find. So how many twos are there? So the number of twos will be 22 IGP here. Okay. And then we have, what is that? The other thing. Let us find out how many fives we have. 5 fives. So then 5 ones. So under 25 factorial, so the IGP of 5 is how much? So 5 plus 1, 6 we have. Okay. So 6 IGP of 5, and so 22 IGP of 2 here. But for every, they are asking what is the IGP of 10 here. So if they are asking what is the IGP of 10, what you need to do? So basically for every 10, we need to have 1, 2 and 1, 5. No matter how many 22s are, how many 2s are there. So you see how many 5s are there. So only 6 5s are there. So this 6 5s can mingle with 6 2s and give us 10. So that means how many tens will be having? Only 6 tens will be having, because we have 6 fives. So therefore 6 fives, even though we have 22 twos, so 6 fives can combine with 6 twos and give us how many, this one? 6 tens. So therefore, whenever they give the composite number and if they ask the IGP of that, then you need to take the least IGP here. So therefore, here the least IGP will be what? 6. Hence, so how many tens are there in 25 factorial? So we'll be having 6 tens in 25 factorial. That means, see, when they give a composite number, take the greatest prime, and that primes. Okay, so IGP is your IGP of this entire number. Okay, what is that we can say? The IGP of that greatest prime number will be the IGP of that. That means the lowest IGP will be the IGP of the given composite number. So that is what we need to understand here. Okay, so this is the thing. Now we have something called as cyclicity. Cyclicity means what? Basically, cyclicity is one of the phenomena. Okay. But we need to identify how the question comes in means, see, 2, 5, 3, 2, 4 raised to the power of 6, 7, 5. So can you please tell, when this number is expanded, what is the number that comes in the unit place? This is a common question that we are going to get. So what is that we'll be getting? So we'll be getting when this number is expanded. Okay. So when this is such a big number, so when it is expanded, so what is that number that we are going to get in the units place? See, when this number so many times, two times, if we multiply only, it will become so big number. But if the same number is multiplied 6, 7, 5 times, you can imagine how many digits will be there. In that, they are very cluelessly they are asking what will be the unit place. Unit means that ones place. How can we identify this? So do we have any method here? Yes. So the method that we use here is cyclicity. That means every number will behave in one pattern, or they have one particular patterns. Okay. What is that pattern means? So whenever these numbers, each of these numbers, so 1 to 9 is raised to some powers, they tend to have the repetitions. Okay. So therefore, let us see for 4. What is the number that is in the unit place? 4. So here 4 is there means I need to see for 4 only. 4 raised to the power 1 is what? 4. 4 raised to the power 2 is what? 16. 4 raised to the power 3 is what? So 64. So 4 raised to the power 4 is what? Another 4 you will be having for the 16. So and then, so that means what? If you multiply into 4, again you are getting 6 only. That means what? After every two, every this one 2, so the repetition is happening. That means the numbers will end with 4, 6, 4 and 6, 4 and 6. That means here the cyclicity is what? Cyclicity of 4 powers will be what? 2 here. So what is that we have? 675. 675 means if 2 divided by 2 means 1 will be the remainder. If 1 is remainder, the first number will be there. That means this number when expanded will end with 4. Okay. If by chance we get 0, okay, that means if the same number 25,324 is like raised to the power of 500. 500 is even number. So when I divide with this 2 cyclicity, so how much you will be getting? 0. So if 0 is remainder, then the number that comes in the ones place will be 6 here. That means what? If you, the cyclicity of 4 is 2. So if 1 comes as remainder, that means you can take like this. If odd number is the power, if the power is odd number, then the number ends with 4. If the even number, if the this one, what is that? Power is even number, then the number ends with 6. Getting it, guys? Did you get this one? Cyclicity. Did you understand what is cyclicity? I'll do one more. For every number, we have this cyclicity. That means from 1 to, see, 1 is always, no matter what power you rise, see, 5, 3, 2, 1, raised to the power of 1, 2, 3, 4. See, I've raised this number to how many times? Okay, that means even if we keep multiplying, okay, here so many times, you will see that always this number ends with what? 1. No matter what it is. Why? 1 raised to the power is 1 is 1. 1 raised to the power 2 is 1. 1 raised to the power 3 is 1. 1 raised to the power 4 is 1. No matter what it goes. So the numbers that's raised to this 1 will be always 1 only. Okay. And the next thing that we have here is what? So for 2. Okay. So let us check the cyclicity for 2. The pattern. 2 to the power 1 is 2. 2 square is 4. 2 cube is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. That means what? After 4, you can see that the cycle repeats. That means the cyclicity for 2 is what? 4. So therefore, for example, if I have the same number, okay, but I'm ending with 2. So if I'm raising it to this power, okay, 2 raised to the power of this one. So what is the number that ends with? Okay, so what will be the number in the unit place? That we need to check. So what we need to do, we need to take the power and divide with 4. Okay, what we need to do? We need to take the power and we need to divide with 4, and then we need to see the remainder here. Okay, so 4 threes are 12. So then take 4. 4 ones are 4. Then 5. So 4 ones are 4. What is remainder? Here we need to concentrate on remainder. The remainder is 1. If the remainder is 1, so the number, this number is ending with 2. If the remainder is 2, okay, if the remainder is 2, so the number ends with 4. If the remainder is 3, the number ends with 8. So if the remainder is 0, okay, so if the remainder is 0, so then the number ends with 6. Okay, so this is what we need to have. For every number, we have cyclicity. It is not just for one number. For every number, you see that we have this cyclicity. For example, 3 also. 3 also have 4 cyclicity. 3 to the power 1 is 3. 3 square is 9. So 3 to the power 4, cube is 27. 3 to the power 4 is 81. You can see what is the cyclicity we have? 3, 9, 7, and 1. Okay, the same way you people need to do. Guys, did you understand how to find the cyclicity of the numbers? Did you guys understand? Yes. Okay. Remember this and try to find for all the numbers. Okay. And 5 is 1 only. 5 to the power 1 is 5. 5 square is 25. No matter if a number is ending with, that means, so 5 cube is 125. If you go like this, so you take the number, for example, 2, 3, 4, 5 raised to the power of 1, 7, 8, 9, 2, 6, 0. Okay. So what will be the number ending with? The number here ends with, blindly we can say that the number ends here with 5. So with what number it will be ending? It will be ending with 5 only. Okay. So now 6, the cyclicity is again what? So 6 to the power 1 is 6. 6 square is 36. 6 cube is what? Into 6 only. 6, 6 are 36. Last number comes in. So 6 only. So that means what? We are going to get, so 6 only here. Okay. So therefore the cyclicity is 6. 5 and 6, it will be 1 only. No matter how many times the numbers will be multiplied, you see that the number comes out to be 1 only. Sorry, the same number, 5 and 6. Whereas 7, what happens? See, 7 raised to the power 1 is 7. 7 square is 49. 7 cube is what? Into 7. So we get 3. Okay. Then 7 to the power 4 is what? Into 7. You will be getting something here. So into 7, 7 9 is 63, 60 minus 7 4 is this one, what is that? 28. So 29, 30, 31, 32, 33, 34. So 343 you will be getting into 7 if you take here. Again, 7 3s are 21. So 2 remainder. So that means what? The number. So with 7, this one has a cyclicity of 4. 7, 9, 3, and 1. Okay. So this is what the cyclicity. So like this, we have cyclicity. So for all 1 to 9, you people find out, you remember them. And as soon as the questions comes like this, you people need to find out. Okay. Especially what is there in the unit place that you need to identify. Now, the last digit of sum or product. Last digit of sum or product. How do you find this? Okay. Last digit of sum or product. How you guys will be finding. For example, I have here 2 to the power of 67 plus 3 to the power of 74. Now, you guys tell me what the number is. Tell me. I have said the cyclicity. Now, you guys tell me how it is. Tell me. Doing. What is the this one cyclicity of 2? 4. 7, 3, 3 also 4 it is. Divide and check. So how much you are getting. So what will be the number that ends here? Which is the number? 8, isn't it? Plus 67 it is. So 67 4 times. So it becomes what? 4 ones are 4. 27. 4 6 are 24. So 3 remainder. Where is the cyclicity of 2? So 3 remainder 8, isn't it? So therefore, I've taken 8 here. Now 74. So 74 again, what is that we have? So 4 is the cyclicity. 4 ones are 4, 34. 4 eights are 32. 2 remainder. So for 3, 2 remainder in the sense what? 9. Now, because they are saying the sum of these number, because this number ends with 8, this number ends with 9. So therefore, so the last digits only will be adding now. So 8 plus 7, 9 is what? 7 will be the last number. So in the unit place, we are only calculating what? Unit place. So in the last place, what you will be getting? So 7 you will be getting. Okay, so this is what our this one is. What is that? I can say the cyclicity rule. This is what. And what will be the product of them? 2 to the power 6. And how does the product of this number ends with? So if you take 8 into 9. Okay. So how much? So what is the number that we are going to get? So 2 will be the last number. 8 9 is 72. So 2 will remain in the number. So therefore 2 is the last digit that we are going to get here. Getting it, guys? Understood? Any doubts? Any doubts? No. Should I move on to other this one? So we have one simple remainder theorem. Okay. Remainder theorem we have. So what is this remainder theorem? Basically, from the remainder, so you guys would have come across polynomials, isn't it? So that is if we have some f of x, and if f of x is divided by g of x, so what is that remainder? So basically x minus something, okay? So when we put substitute in this x, so then we are going to take this. For example, let me take the equation x square plus 2x minus 3 when it is divided by x minus 1. So what you will be getting from the polynomial equation. So the this one divisor here is what? X minus 1 is equals to 0. This is the divisor. That means here I'll be taking x is equals to plus 1. What I'm doing here, I'll be taking x is equals to plus 1. So what we'll do, 1 square, wherever x is there, we'll substitute the value 1 square plus 2 times 1 minus 3. So 1 plus 2, 3, 3 minus 3, 0. That means it is 0. The remainder is 0. That means what I can say that. So this x minus 1 completely divides the given number. So this is our remainder theorem. Okay. So what is this? You remember this as remainder theorem. So now on the basis of that, so if they ask us to find out, so how we can basically divide the thing. So now, for example, 2 raised to the power 54 divided by 7. What is that we have? 2 raised to the power of 54, and that is divided by 7 we have. Now, this is like this one. How we can calculate this? What is that particular thing we can do? So we can do, okay, this 7. Can I express in whatever the number so they have given in terms of 2? Yeah. So we can take 2 square is 4. 2 cube is what? 8. But we need what? 7 here. So what I will do, 2 cube minus 1 I'll be taking. Okay. Why I'm not taking 2 square plus 3? That means this 3 is very big number. If I start substituting in this place, it will become very, calculations becomes difficult. So basically, I'm expressing 7 in the form of x minus 1. What I'm doing? So I'm expressing 7 in the form of x minus 1. So therefore, so what is that? So 7 can be expressed as 2 cube minus 1. What we are going to do? 7 will be expressing as 2 cube minus 1. So 254 divided by 7. 7 is what? 2 cube minus 1. Let us see how many cubes two, this one is there. What is that? Three twos are there. So try to see. 54, na? 3 times. How many times? 3 ones are 3. So 24. 3 eights are 24. That means what? So 2 cubes, how many are there? 18 we have. Okay. So 0 we have. So 2 cube of 18. So divided by 2 cube minus 1. What we have done, I've splitted this 2 to the power of 54 is equals to what? 2 cube of 18. Why? 2 to the power of 54. 3 into 18 is 54. Isn't it? So I've split like this. 2 cube into 18. So it is not. See, 2 cube of 18 like this, and then 2 cube minus 1. According to this, what I need to do if I want to find out the remainder, so let me take x minus 1 form. That means 2 cube is equals to 1. So wherever 2 cube is there, I'll be shifting this 1. Therefore, 1 raised to the power 18 is the answer. 1 raised to the power of 18 is what? 1 only. That means what is the remainder we get? The remainder here is what? 1. Getting it? What is the remainder? The remainder here is 1. Did you guys understand this remainder theorem? Did you guys understand or no? No? Yes. Okay. Let us do one more problem. The same thing, I'll say 2 raised to the power of 201 by 5. Guys, so now what we'll do, we'll focus on 5 here. And since we have some raised powers, what we need to do is, let us try to, in terms of 2 only, let us try to shift this. Okay. So what we can do here is that, so 2 raised to the power 2 not 5. So 5 can be written as what? 2 square plus 1. Okay. So what I am doing? 2 square plus 1. So this can be written as 2 into 2 raised to the power of 200. Isn't it? 2 raised to the power of 200 divided by 2 square plus 1, which is nothing but 2 into 2 times 2 into 100 divided by 2 square plus 1. So now here what happens? We know that 2 square is equals to minus 1. What is that we have? 2 square is equals to minus 1. Why? Because I am taking 2 square plus 1 is equals to 0. So 2 square is equals to minus 1 we are going to take. So this becomes 2 into, okay. So what is this? Minus 1 all raised to the power 100 divided by 2 square plus 1. So this is already divisor, so we don't need to take here. So therefore this becomes 2 into, see, since even number, to even number it is raised. So if a negative number is raised to even number, the number becomes positive. If we had a positive number here, sorry, if we had a odd number, then that multiplication would become minus 1. 2 into 1 is 2, so therefore the remainder is what? 2 here. Getting it? What will be the remainder? So the remainder here will be 2. Any doubts here? If no doubts, then I'm going to go for next questions. Okay. So these are some of the topics on numbers that you people need to remember. Okay. So now I'm be shooting the questions at you guys. So I want you people to answer them. So in a radio tower, in a radio tower, let me share the screenshot. Okay. On a radio tower, we have a red light flashes every 6 seconds. Okay. Every red light flashes what? Every 6 seconds. Okay. What is that they are saying? Red light flashes every 6 seconds and blue light flashes every 10 seconds. If both light flashes together at certain time, they are saying that, so the both the flashes at certain times they will flash. How many seconds later, okay, how many seconds later will both lights flashes together the next time? So that means here they are asking, so red light, see, whenever we get such type of question, these are LCM based questions. Okay, what it is? These are LCM based questions, and you people so need to, whenever we get some question like this, so you need to be aware of these particular things. So what is that they are saying? So red light flashes 6 seconds once. So blue light flashes so 10 seconds once. Okay, but at certain time they flashed both red and blue. Okay, now how many seconds later? They are not asking at what seconds, how many seconds later they are going to flash together. So you can see, take the LCM here. 2 threes are 5s are, then so 3 ones are 5s are, so 5 ones are 15 and 13. So every 30 seconds, what they are going to do, they are flashing together. No matter when they started, because they are not saying first time. Okay. So that second time we can calculate. They are saying at certain time they flash together. So, but we know at what seconds they are going to flash together. Here you will be seeing that every 30 seconds they flash together. That means after this time, after 30 seconds, they are going to flash. So therefore, what is the answer here? 30 seconds will be our answer. So what is this answer? So 30 seconds. Now, got it, guys? Did you guys understand? Any doubts? Okay. So any questions like this, kindly focus on this one, LCM. If A is less than, see, if I put this one, what is that? The complete slideshow. So then I won't be able to draw here and explain. Okay. So that's the reason I'm using this, what is that? This one PPT is one by one only. Okay, kindly, I guess it is very clear, visible, so you people can understand. Here they are saying what? A is less than B b is less than 0. Which of the following numbers should be positive? Now find out. Indicate all such numbers. So that means A is less than B. B is less than C. Sorry, 0. That means both the numbers should be what? Negative numbers, isn't it? Both the numbers are negative. Why? Less than 0 means negative. A is less than B. That means B should be greater than A. Let me take B as 4. Let us take the example and try to find. When they give some questions like this, it's better always to take example. So minus 4 let us take and A as minus 5. Why? Because minus 5 is obviously lesser than minus 4. See, whatever yesterday we discussed, that came into this one. So now here what happens? Minus 5 minus of minus 4. It will become what? They're asking which number to be positive. Minus 5 plus 4, it is minus 1. So this is not our choice. And here what happens? It is minus 5 whole square minus of minus 4 whole square. It is 25 minus, so 16, which is 9. Therefore, this is positive. So you can tick one of this. It's not only one. When they give the square boxes, that implies multiple answers are this one. And here they have the product. Product in the sense negative into negative, positive, isn't it? So we can aram se say, because both the elements are negative, hence what we can do, so we can take it as positive. So B, C also goes on. Whereas here it becomes, what is that? Again, negative will be there. So why negative? See, minus 5 whole square into minus 4. So this all will become positive, but positive into this negative is what? So negative only. So therefore, this also will not go. Whereas a square plus ab square, here also what is that? A square b is negative plus ab square is again negative. So negative, negative when we had, we are going to get negative here. So therefore, E also will not go. So therefore, what is that we have? Only B and C are the correct options that we have here. Getting it? Any doubts? Good, guys. Now, how many positive integers are the factors of 100? Yesterday we did this, isn't it? So what is the number of factors? Number of factors, if the number of factors, it is present in a to the power p, b to the power q, c to the power r. So if the number is expressed like this, the number of factors will be given as p plus 1 into q plus 1 into, so r plus 1. It goes like this. So can you guys tell me what is the number of factors that we are going to have here? See, 10. How can I simplify? I'll give you once again. So, 250s. So, 225s. So, 5 5s. So, 5 ones. So, the number could be 100, could be split as what? 2 square into 5 square, which is nothing but, so the powers of 2 and 2. So, therefore, 2 plus 1 into 2 plus 1. So, which is nothing but, so 3 into 3. So, we have 9 factors. And what are those 9 factors, guys? So, the 9 factors are 1, 2, 4, 5, 10, 20, 25, 50, and 100. Got it? So, these are some of the, this one, what is that? Factors that we basically have. Now, you guys got it now. I used the same formula and we did it. Okay. So now, here they are saying a student made a conjecture that for any integer, okay, for any integer n, the integer 4n plus 3 is prime. What is that they are saying? A student made it that for any integer we take for n, so it should be a prime number. Which of the following values of n could be used to disprove the student's conjecture? That means we need to, when we substitute the given thing here, okay, given values of n, so when we are not going to get the prime numbers, that means we need to disprove, in the sense what we should say, like the student is wrong here. Okay, what we need to do, we need to say that the student's thing is wrong, that is 4n plus 3 so is wrong here. Okay, so that we need to identify. What you need to do, simple. So when n is 1, so 4 3, 7 we have. 7 is a prime number or a composite number? It is a prime number, isn't it? So what we are going to do, 7 is a prime number. So we are going to take, okay, this is correct. But we need to take out the thing which is incorrect. Okay. Next, 4 into 3 plus 3. 12 plus this one, 15. It is not a prime number. It is a composite number. So I can take when n is 3. So this is not true. Let me take, because it's the square boxes. When we have the square boxes, what will happen? So they are going to, more than one answer could be correct here. Okay. Then I'll take 4 into 4 plus 3. So 16 plus 3, 19. 19 is a prime number. Therefore, 4 is also like, what is that? Proving the conjecture. But if I take 4 into 6 plus 3, only n is changing. 24 plus 3 is what? 27. Whether 27 is a composite number? It is composite number. Why? It is divisible by 3 there. So 6 also cannot be. Now, if I take 4 into 7 plus 3. So 28 plus 3, so is how much? 31. So 31 is a prime number, hence I can take this. So what are the answers that's correct? B and E. Got it, guys? B and E should be taken as our correct answers. Now, yeah, you guys got it right? Since I'm explaining, so I'm taking. Otherwise, it takes seconds for us to do these things. Now, if minus m by 19 is an even integer, which of the following must be true? Okay. See, one concept you people remember, if odd number, when any odd number is dividing any other number, if we are getting a even quotient, that means what? So the number which has to be divided should also be even here. Okay, should be even, because if we have odd divided by odd, will be odd only. Remember that. Even divided by odd will be what? Even. Remember that. Okay. So that's the thing we basically have here. So if that is the case, and it doesn't matter what is that, whether negative or positive, it doesn't matter, because even numbers, so even negative even numbers also we are going to have. So therefore, m cannot be negative. That is not very important for us. M is positive, that also doesn't matter. If m becomes a prime number, how can one prime divide the another prime and we get a even number? So then that will be the simplest fraction. It cannot happen. If m is a odd number, odd divided by odd is what? Odd number. So m has to be what? Even number. What the m has to be? M has to be your even number. Getting it? Now, huh? What is the least positive integer that is not a factor of 25 factorial and is not a prime number also? Now we need to pick up, so one number here which is not prime also and which cannot be the factor of 25 factorial. because they are talking about the 25 factorial, so we need to be very careful. We can't say anything about 25 factorial. We need to have with thing. Let us start splitting the numbers here. Okay, what we do? Let us start splitting. 2 into 13. Okay, it's 26. So then 2 into 14 is 28. So if I take 2 into, so what is that? 18. This again I can write. So into prime numbers, 2 into, so 2 into 9, which is further can be written as 2 into 2 into 3 into 3. Okay. So then again, this is what? So 2 into, so 2, how many times it goes? 56, right? So 2, 2 is 4, 1, 28 times. So 2 into 28. So again, it can goes like 2 into 2 into 7, because this again can be written as what? 2 into 2 into, what is that? One more 2 will be there. So 2 into 2 sevens are 14. Okay. So this is the thing we have. And here if we take, so 2 into, how many times it will become? 29. 29 is the prime that we have here. So therefore, because 29, see, rest of the primes, if you see, all of these numbers are very much present under 25, isn't it? So even though they are composite numbers, if I further split these numbers, you can see that under 25, all these numbers are there. You can see when I split them up, so all these prime numbers, everything is available. So therefore, what is that we can say? So all these are factors of 25 factorial. But so if you take 58, if you see 2 into 29, even though 2 is present, but 29 is not present there. So therefore, what? This is that one number, so which is the least positive number. So that cannot be the factor of 25 factorial. Okay, getting it? So you need to split up like this, and you need to understand the things. I mean, you need to, it's just simple factorization we are doing, especially the prime factorization we are doing, and we are finding out here. Now, yes, we have one more thing here. The integer v is greater than 1. So here, what is that? V is greater than 1. What is this? V greater than 1 we have. So if V is the square of a number, V is greater than 1 and it is the square of some number. Okay. Which of the following numbers must also be the squares of an integer? Okay. Let me take V is, what is that? Square of the number. So I'll take 2 square. Let me take V is equals to 4. Okay. So if I take V is equals to 4, 81 into 4 is how much? 324. Whether 324 is the square root of 324 is what? 18. So, okay. So this is also a square. Okay. If I take 25 into 4, here you can see, plus 10 into square root of 4 plus 1, which gives us what? 100 plus 10 into 2 we get. Okay, why? Because square root of 4 is 2 plus 1, which is nothing but 121. 100 and square root of 121 is 11. Okay, so because they're asking, even when we expand these things, that should be the square of the number. So following numbers must also be the square of the number. That means we are getting 121. So if I take the square root, it is a perfect square. Even this is also a perfect square. So now if I take, so 25 into, so b square they are taking. That is 4 square, sorry, 4 into v square. V square is what? 16 plus. So why 4 square? Na? So 4 times root of, so 4 plus 1. So 16 fours are 64 plus 4 twos are 8 plus 1. So how much you are getting? So 64 plus 8, 72. 72, 73 we are going to get. Whether this is a perfect square? No. So only A and B can be our answers. Okay. So what is this? A and B only can be our answers for this, which proves so that the given equation can also be a square of a number. Getting it? Okay. So now guys, any doubts you people have? Do you guys have any doubts? Any doubts you have? Okay, good. Okay. So kindly do these things because these things plays crucial role. Okay. And we'll see you tomorrow with more topics like ratios, percentages, and all of these things. And we'll be discussing here. Okay. So, right, guys. Thank you so much. Bye.
Thank you, ma'am. Also, if anyone has any doubt related to the Ubergrad website, you may ask now. Thank you.